Hi everyone. In this video, we'll be seeing about thermodynamics, concepts of thermodynamics and laws of thermodynamics. So first, we shall see about what is thermodynamics. So thermodynamics, it is a branch of physics which is concerned with the relationship between the forms of energy and heat. So thermodynamics means it is about thermal, that is heat. It completely deals about the heat and its surroundings. So the thermodynamics, it deals with the study of heat, energy transformations and its relationship with the properties of matter. The thermodynamics, it provides a important relationship among heat transfer, work interaction, kinetic and potential energy. So there are various applications of thermodynamics includes turbines, pumps, engines, compressors, air conditioners, etc. So these are some of the examples of a thermodynamic system. So this is a system where the heat concentrated. So the area where the heat is concentrated is called as the system, and the line to which we are seeing it is considered is called as the boundary, and the remaining place around the system is called as the surroundings. So these things comes under the basic concepts of thermodynamics. So when we look about the basic concepts of thermodynamics, the first most thing we need to see is about a system. So for example, consider a room in which the heat is concentrated. So that room is considered as a system. So it has a boundary, and within that the space within the room is considered as a system, and the walls that is surrounded by the room is the boundary. So it is a real or imaginary surface that separates the system from its surroundings. So the space left out other than that room is called as the surroundings. So boundary is nothing but it may be a real surface, or we can imagine that within this area we are doing the heat concentration. So apart from this, other things are surroundings. So a imaginary or a real surface that separates the system from its surroundings. So the boundaries of a systems can be fixed or movable. Mathematically, boundary has a zero thickness, no mass, no volume. So the first basic concept is about a system where is defined as a quantity of matter or a region in a space or chosen for study. The mass or region outside the system is called as surroundings. And the next one is closed system or a controlled mass. It consists of fixed amount of mass and no mass cross its boundary, but energy in the form of heat or work can cross the boundary, and the volume of a closed system cannot be fixed. And the next one is open system or control volume is a properly selected region in space. It usually encloses a device that involves mass flow such as compressor. Both mass and energy can cross the boundary of a control volume. And the next basic concept is about state of a system. So the state of a system is a condition in which a system at a specific time, which can be identified by values of a suitable set of parameters like pressure, volume, temperature, mass, etc. So at this moment, in this room temperature, this is the pressure, this is the mass, this is the volume. So all these things are put together as the state of a system. And the next one is cycle. Thermodynamic cycle is defined as a linked sequence of works. So the continuation of process that takes place within a system is called as the cycle. And the next one is internal energy. Internal energy is the energy possessed by a body or a system due to its molecular movement, and it is mentioned as denoted as U, and it is a sum of potential energy and a kinetic energy. So the next one is enthalpy. Enthalpy, it is a measurement of energy in a thermodynamic system. The quantity of enthalpy equal to content of a heat of a system. So the total amount of heat present in a system is called as the enthalpy, which is equivalent to system's internal energy plus the product of volume and a pressure. So mathematically the enthalpy is given as H, which is equal to sum of internal energy. Here they are mentioned internal energy as E, and plus product of pressure and volume, which is P and V. So this is the formula used to calculate the enthalpy. And the next one is entropy. So entropy is a thermodynamic quantity whose value depends upon the physical state or condition of a system. In other words, it is a thermodynamic function which is used to measure the randomness or disorder of a system. For example, the entropy of a solid where the particles are not free to move is less than the entropy of a gas where the particle will fill the container. And the next one is temperature. So temperature, it is a physical property of matter that quantitatively expresses hot and cold. It is a manifestation of thermal energy present in all matter, which is a source of occurrence of heat. So the temperature, it indicates that whether the system is hot or cold. So if it is above the fixed value, so it is mentioned as hot, and if it is below the value, it is mentioned as cold. So however, a flow of energy when a body is in contact with other, that is cold. So this is about the temperature. And the next one is heat and work. So heat, it is defined as the transfer of energy without transfer of mass taking place across the boundary of a system or between two different bodies due to the temperature difference between them. It is important to note that heat is transferred naturally from a body of a higher temperature to body of a lower temperature, and it is denoted as Q and expressed in kilojoule. And the next one is the pictorial representation of a flow of heat. So in these two diagrams, there are two conditions where heat added to system. So when a heat is added to the system, it is considered as positive, and when if in the condenser the heat is rejected out, and here the heat is taken as negative. So whenever a heat is added to the system, it is considered as positive, and when a heat is rejected from the system or by the system, it is considered as negative. And the next one, work. So in a thermodynamic, work refer to energy transfer between the system and its surroundings, whose sole effect on the things external to the system can be converted into raising a weight. The weight may not be actually raised, but the net effect external to the system should be similar to rising of a weight. In simple words, the work is a transfer of energy associated with the force acting through the distance. It is denoted as W and expressed in kilojoule. So if you take the sign convention of the work done, when the work is given to the system, it is considered as negative, and work is given by the system. When the work is exerted, it's done by the system, it is considered as positive, and when work is done on the system, it is considered as negative. So it is similar to exactly opposite to that of a heat. For a heat, when a heat is given to the system, it is considered as positive, and when the heat is given by the system, it is considered as negative. Whereas in work, when the work is given to the system, it is considered as negative, and when the work is given by the system, it is considered as positive. So this is about the heat and work.